Hello everyone, welcome to the channel. Today we want to find e to the power of I. E raised to the power of the complex unit I is our question today. Before taking this, let me tell you about the polar coordinates and Euler's formula. Now any complex number on the complex plane, let me show you the real and imaginary axis. Any complex number a plus bi, let's say this z is equal to a plus bi, then the real part is a and the imaginary part is b, and this length here is r. Let me show you here. This r is equal to root a squared plus b squared. And this angle here, theta, then we just write a is equal to r times cosine theta and b is equal to r times sine theta. So z becomes z, which is equal to a plus bi, becomes r times cosine theta plus r times sine theta times I, which can be written as r times cosine theta plus I times sine theta. And this cosine theta plus I times sine theta is notated as e to the power of I theta by Euler. This is the polar form for any complex number. Now, we will use this to find this e to the power of I. We have the question is e to the power of I is equal to what? Now, as we found, let me write again. We have e to the power of I theta is equal to cosine theta plus I times sine theta. So e to the power of I can be seen as e to the power of I times 1 actually. So this is equal to cosine 1 plus I times sine 1. And this cosine 1 is approximately 0.5403, and this sine 1 is approximately 0.8415. So e to the power of I principally is equal to 0.5403 plus I times 0.8415. Actually, the general result for this is e to the power of I is equal to cosine 1 plus 2 pi n plus I times sine 1 plus 2 pi n. This n is any integer. This is the general result for n being any integer. Thank you for watching and see you in the next videos.